All right, today, the problems, you'll just have to, sorry about the stuff at the top there, but without trying to look at that, this is going to be video of one scale problem we're going to practice together. And this is a problem about Chloe. Okay, cool name. Chloe has made a scale drawing of the gym floor. And luckily the gym floor is just a rectangle, so it's pretty nice. The scale drawing, pretty simple. Okay, so remember scale drawing, this one shrunk down, the gym floor is massive, and she's shrunken down to 3 centimeters by 2.4 centimeters using the scale, and that scale is every centimeter equals 4 meters. So what we want to know, 2 parts to this. What are the actual dimensions of the gym floor that she drew? Well, this scale is super important. You have the drawing dimension and you have the actual real life dimension. So if we're thinking about this 3 centimeters in the scale drawing is worth how much in actuality? So in part A, I need to get what 3 centimeters is in real life in this gym floor. And then what is 2.4 centimeters going to be in actuality with the real gym floor by making use of this scale. So let's try this. Part A, 3 centimeters. So if we first look at that one, we know every centimeter is worth 4 meters. So if that's not helping you get it instantly, you could set up a proportion here, and one side of the proportion is going to be our scale. That gives me a ratio. Every centimeter is worth 4 meters. And then on this side, I'm going to fill it in with, well, we're trying to convert this dimension into real life. So I need 3 centimeters to go on the top because that corresponds with the 1 centimeter over here. And then I need to find this amount. I need to know how many meters this would be. So some of you could see a relationship happening here, where 1 times 3 will give me 3, so I do the same thing here. Or, let's say you do that, so you multiply by 3. So that means this is going to be 12 meters in actuality. Or maybe you didn't see that relationship. Maybe you saw this one. 1 times 4 is 4. So I'm going to take 3 times 4, and guess what? I get the same thing, 12. Either way we get it. All right, we got one dimension. Now we need this dimension of the gym floor. In the scale drawing, it was 2.4 centimeters. So I need to convert that into what it is in meters in actuality. So I have to make use of this scale again. So one side of my proportion is going to be the same thing. And the other side, I'm going to have 2.4 centimeters on the top, corresponding to the centimeters over there, numerator. And I'm trying to find this. So I could get either relationship I want. If I don't want to multiply by a decimal, then maybe I go this way. 1 times 4 is 4, so I'm going to take 2.4 and multiply it by what? 4. So 2.4 times 4 gives me 9.6 meters for this part. So I figured out the actual dimensions of the gym floor. Actual dimensions were 12 meters by, just had it, 9.6 meters. That's a 9. Okay. Part B, another part of this. If Chloe makes a new scale drawing of the gym floor using a scale of 5 centimeters equals 8 meters, what will be the width and length of her new drawing? Okay, so she already made a scale drawing, right? But she used 1 centimeter equals 4 meters. She's like, I want to change this up. I don't like it. So I want to redraw this gym floor that has the dimensions. These are the actual dimensions right here, you guys. So now we need to take these dimensions, the actual dimensions, and convert them into our scale measurements, knowing that we're going to use the scale every 5 centimeters is worth 8 meters. So I'm going to redraw this. This is where I'd start. The actual gym floor is 12 meters by 9.6 meters. I need to know my new scale drawing, what is it going to be in centimeters? And you're like, we already had that, 3 by 2.4. No, but that was with a different scale. So now I need to use this one. So to figure out this amount here, and to correspond it with 12, guess what? I'm going to set up a proportion. And one side of the proportion is going to be my scale. Every 5 centimeters is 8 meters. And then I'm going to put this 12 in there. That's 12 meters, so that's going to go on the bottom because it corresponds with the 8 meters. And I'm going to figure out what that will be, what that dimension will be. And the thing is, in this case, I do not see a relationship happening between 5 and 8. And I don't see a relationship with the 8 and the 12. So how the heck do you do this? Well, guess what? Algebra comes back to get you. So to find this question mark, I draw my line down and I'm going to do some algebra here. I need to get rid of division by 12. How do we do that? Multiplying by 12 on both sides. Since I did that, those will go away. So to find this question mark amount, I have to take 5/8 times 12. 5/8 times 12. 12 as a fraction would be what? 12 over 1. I could cross reduce. Definitely try to do that. 8 and the 12 both divide by what? 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. And then I'm going to multiply across. 5 times 3 is 15. 2 times the 1 is 2. We're almost there. This is improper. So I'm going to convert it into a mixed number. 15 divided by 2. 2 goes into 15 7 times. So this is 7, but not perfectly. We're going to be left over with something. And we're left over with 1, and we are divided by 2. So this dimension in my new scale drawing is going to be 7.5 centimeters. Now I need the other dimension. I need this one. And guess what? We're going to do the same thing. Just with different, we're not going to use the 12 meters this time. We're going to use this, the 9.6, because that corresponds to our other dimension. So what proportion are we going to use? Well, the scale is still going to go in it. So I'm going to have 5 centimeters to 8 meters equals something over 9.6 meters, because we correspond the meters with the meters. And there's going to be no relationship happening either way. So guess what? We're resorting to algebra one more time. So 5/8 equals question mark over 9.6. I would let you make use of a calculator here when you're doing the algebra, but I'm going to draw in my line. I'm going to get rid of this division by 9.6 by multiplying by 9.6. So now the question mark is going to equal whatever this is. So I'm going to write out what that is. 5/8 times 9.6. And now, what would I do on the calculator? There's many different ways you could approach this. But let's say I made 9.6 a fraction, so that's 9.6 over 1. Then I just multiply across. So let's get our numbers. Let's do 5 times 9.6 on the calculator. 5 times 9.6, and I'm at 48. So that's going to be 48. Over 8 times 1. I don't need to do that on a calculator. That's 8. And oh my gosh, I'm not going to need a calculator because this goes in perfectly. 48 divided by 8 is 6. So my dimensions of this new scale drawing are 7.5 centimeters by 6 centimeters. 7.5 by 6. 7.5 centimeters by 6 centimeters. And that should give us the same area as the gym floor from the beginning. We're going to practice with some skill again in class tomorrow. See you then.